Hi, Dr. Lanier. I'm going to explain this bonus assignment. So, on part A, we have a mass spec with a parent ion with 119. We do our little division, and we get C9, H11. We know the parent ion is 119. So we know that there's an odd number of nitrogen, so we go ahead and throw a nitrogen in there. And now we're at C8, H9, and 1. And that gives us 119. That's in the corner right there. Okay. So all is right with the world. We get our IR spectrum. We get a 3,512 frequency that's broad and strong. We always know that that is associated with an alcohol. Is the pink? We get a medium kind of double peak at 3301 and 3359. We know that that is an amine nitrogen with 2 hydrogens coming off. That's highlighted in yellow. We also get a 3398. One that is highlighted in blue, and that one comes from in a mead group. It's right here, RCON, and I assume it's the NH2 because of the other one. So it is right there in blue. And then we get a 1640 one. That is a carbonyl attached to an amide. So that's highlighted in green. I assume that's the RCONH2. All right, so go back. We, with our IR data in mind, determine a second possible chemical formula. Which chemical formula best fits the data? We tinker with our other formula a bit. We know we have to add an oxygen in because we have that carbonyl group, and we know we have to add at least 2 oxygens in because of the alcohol group. So the first formula I came up with was C5H13O2 and 1. That one doesn't make any sense because it's too saturated with hydrogens. So we tinker with it a bit more. I tried adding 2 more nitrogens to get N3 and have an odd number of nitrogens still. That didn't work. And we ended up tinkering and getting C4, H9, O3, N. And then we do our little unsaturation part, and we end up with 1 degree of unsaturation, which we know we have to have at least 1 degree of unsaturation because of that carbonyl. On our C13 NMR spectrum below, gives us a little more information. We know we have 4 unique carbons. We have a sp3 carbon, and then we have 2 sp3 carbons attached to either an N or an O, and then we have a carbonyl. On the H&MR spectrum, we have our first doublet. This is going to be a methyl group, CH3. And then we have on the next one, it is another doublet. I'm assuming this is our carbon attached to that carbonyl group, the OC-C with one little H sticking out. It's highlighted in blue on our structure. And then we have a multiplet, which is highlighted in pink, and that is going to be our hydrogen attached to our carbon attached to an alcohol group, also highlighted in pink. And then we have a green one right here. This one is near 5. We know it's de-shielded. So this is going to be one of our alcohol groups, probably the alcohol group that is attached to the carbonyl to become more de-shielded. So it's ROH, and that's highlighted in green. So going back to that, all OHs are going to be singlets. So that ROH, see if we can look at it right here, is a singlet. This NH2 does not show up on our NMR. This OH does not show up on our NMR. This H right here, it has 2 neighbors. It ends up being our multiplet. This these 3 CHs right here, it has 1 neighbor. It ends up being our doublet. And then this blue H up here has 1 neighbor. It also becomes another one of our doublets. They don't interact with the NH2s or the alcohols at all, and this is what I came up with. Hi, supplemental. Say this real quick. Going back to our mass spec, we have significant ions with a value of 104, 74, 45, and 15. On my paper, I will show you where those are cleaved to make that. We have an alpha cleavage right here, and that alpha cleavage gives us our 74 and 45 if we do the math up. And then if we cleave off this CH3 group down here, we get our 15 and 104.